Thanks for clicking. Welcome to another Nargilus production. Today, we're going to be talking about the first derivative test that we've already looked at algebraically, analytically, and we are going to look and apply the first derivative test graphically to a given graph. Okay? All right, so let's get started. We'll see how it all works. We'll review that first derivative test real quick. So here it is. What can the first derivative test tell us about a function? So these are all the things that we looked at analytically. Let's do a different color. Analytically the other day. So if f prime is positive, then we know f is increasing, right? When f prime is negative, f is decreasing. If f prime changes from positive to negative, that means f would change from increasing to decreasing. There's a relative max there. F prime changes from negative to positive. That would mean f would change from decreasing to increasing. There's a relative min there. Okay, so this is what the first derivative test can tell us about a function. Now, what we're going to do is we're going to start to look at this graphically. Same concepts. We're going to use these concepts, but we're going to use them graphically instead of algebraically. Okay, so here's my question. This shows up on the AP exam all the time. Those of you that might be taking an AP exam. Here's the graph. This graph that's given. This graph that's given is not the graph of f. It's the graph of f prime. So this is the graph of f prime of x. It's the derivative of f. Now, first thing you need to notice is, if you look at the first three questions, A, B, and C, and we're going to do them in a different order, not the order here, you can see what I'm asking you. Name the x value or values on the interval between -7, 7 for which f of x has a critical point. F, not f prime, f. F of x is not the graph that's given up here. Same thing here. On what interval or intervals is f increasing? That's not the graph that's given. I'm given f prime. Okay? All right, so we're actually going to start with letter B. All right? It wants to know on what interval or intervals is f increasing. Explain your reasoning. All right. So here's how this works. I want f to be increasing. But I don't have the graph of f. I have the graph of f prime. So how does f prime tell me information about f? Well, if I go back, okay, if I want f to be increasing, then f prime has to be positive. So f prime has to be positive. So the question is, where is this graph of f prime positive? Where's it greater than 0? So it's greater than 0 here, all through here, not there, there to there. So f is increasing on the interval from, this is -6 over here. That's 6 over there. From -6 to 0 in the union with 0 to 6. Now, why did I leave out 0, right? How come I just didn't go from -6 to 6? Because at 0, f prime is not positive. It's 0. So I can't count that in my interval. It's not positive at 0. It's just 0. So on what intervals is f increasing? Well, from -6 to 0 in the union 0 to 6. Explain my reasoning. Reasoning is simple because f prime is positive. That's it. That's all you have to say. Okay. On what intervals is f decreasing? All right, so now I want to know where f is decreasing. Okay. So f is decreasing. Well, I want f to be decreasing. So what do I know about f prime? F prime has to be negative, right? So that's going to be, where's f prime? Below the x-axis. From there to there, and then from there to there. All right. And we're only working on, this says -7 to 7, but I'm going to call this 8, okay? 8. And we'll say this is -8 because it's a little further out. So we'll say it's, where's f prime negative? It's negative from -8 to -6 in the union with 6 to 8. Again, I'm counting the 8. I'm counting the -8 because it's negative there. F prime is negative there. Reason? Because f prime is negative. That's it. That's my answer. All right, now let's go back up to A. Name the x value or values on the interval -7 to 7. Okay, -7 to 7. So that would be from there to there, for which f has a critical point. All right, so what's it mean for something to be a critical point? Well, think about it algebraically. What would you do? If I gave you f of x was equal to x squared minus 3, and I said here, 3x, and said, here, go find the critical numbers, what would you do? Find the derivative, right? Set it equal to 0. That would be your critical numbers. So the critical numbers are where f prime of x is equal to 0. Okay, they only want me to name the x values. So the x values where f prime of x is equal to 0 are x equals -6, x equals 0, and x equals 6. Those are the three values. So now I want you to classify each critical number as a relative min, a relative max, or neither. Okay, what does that mean? Well, f has a relative min. That means f would have to go from decreasing to increasing, right? So f prime would have to go from negative to positive. Okay, let's take a look at -6. At x equals -6, right before -6, f prime is negative. Then it switches at x equals 6 and becomes positive right there at that point. Right? These are my three critical numbers. All right. So now at x equals 6, -6, there must be a relative min. Why? Because f prime changes from negative to positive. Okay. Let's try x equals 0. At x equals 0, what happens? The graph is positive, but then it stays positive. So think about it. If you're on your number line and f prime were positive, then it would stay positive. X equals 0, you'd be like, nah, that's a nothing. Right? So x equals 0 is neither, because f prime doesn't change sign. It's positive, then it stays positive. What about at x equals 6? Well, before it, f prime is positive, then it switches and becomes negative. If f prime is positive, that means f is increasing. Then f prime is negative. That means f is decreasing. So there's a relative max here. Why? Because f prime changes from positive to negative. And that's my answer. Okay, that's all the justification you need. That's everything. All right. Okay, let's keep going. Same graph. Still the graph of f prime. Now I want to know on what interval or intervals is f double prime positive. Okay, so now I want f double prime to be positive. But I don't have f double prime, I have f prime. So what is the relationship? If f double prime is positive, if the derivative is positive, the one before it has to be increasing. So the question is, where is this graph increasing? Well, there and there. So we name increasing and decreasing by x values. So again, we'll call this -8 just to call it something. So we're going to say from -8 to -3, x values only, in the union with 0 to 3. Reason? Because f prime is increasing. And finally, letter E, would the mean value theorem apply to f of x on the interval -7 to 7 closed? So from there over to there. Well, mean value theorem, what the heck does this have to do with anything? Mean value theorem, that's the place, that theorem is when the A rock is equal to the I rock, right? But what has to be true for the A rock to equal I rock? What are the conditions by which you need to make that mean value theorem work? Okay, what do you need to know about F to figure out if the mean value theorem can even apply? Well, F has to be continuous and differentiable. So the question is F continuous and differentiable? Well, let's take a look. Well, this is not the graph of F. It's the graph of F prime. Okay? F prime is, oh, no, you know what? Let's do this instead. I'm going to change this. And I want to know, would the mean value theorem apply to F prime on the interval? So F prime will have to be continuous and differentiable. That's the question I really want to ask you. So is F prime continuous and differentiable? No. I claim it's not. Is F prime continuous? Yes. Is F prime differentiable? No. Why not? Okay. Because there are corners here, there, and there. Right? There's two slopes there. One positive slope, one negative slope right there. One negative slope, one positive slope right there. So this thing's not going to be differentiable at these 3 points. So would the mean value theorem apply to F prime on this interval? No. Why? Because F prime is not differentiable at x equals -3, 0, and 3. There are corners there, 2 slopes. And that's the correct answer. Okay? So that's what we're going to do here. We're going to take graphs and use graphs to figure out information about other graphs. All right? Using that concept of the first derivative test. Okay? And that's it. And as always, thanks for clicking.